Hello, everyone. We are doing the hydrosphere. Now, again, I'm just going to briefly go over the water cycle and surface water. So remember, 97% of the hydrosphere is oceans, 3% is fresh water. Here are your steps for the water cycle: evaporation, condensation, precipitation, infiltration, transpiration, runoff, sublimation per location. So today, from this picture here, we're going to understand this picture a little bit better because today we're going to talk about groundwater. We're going to understand the wells and how runoff goes with the wells, unsaturated zone and saturated zone. And we're also going to understand when the water does fall. So, surface water review. Please remember, runoff is just excess water that does not permeate into the land and it flows over the surface instead. Okay? So, runoffs again may reach streams, rivers, lakes, and they also may evaporate or accumulate and seep into the ground. Also, remember surface water streams. A stream is a channel with permeant water flow. Trip Tributaries are streams that flow into each other, which is basically increasing the size of the stream. Okay, the larger the stream is, we know those to be rivers, and if you have a lot of tributaries, they make up a river system. Okay, the smaller ones are the creeks and brooks. One thing you do have to know, and as I tell you in class, there's some parts of your notes you do have to know. You have to understand the difference between a V shape and a U shape, okay? So V shape is a young stream, U shape is going to be more mature, okay? You have to know these three types of loads, okay? Solution, suspension, and bed load. And again, you want to know that meander is the bend, okay? So here we are with today's notes: hydrosphere, groundwater. Our standard EEN 232A. Illustrate the water cycle to explain the connection between groundwater and surface water, detailing how groundwater moves through the lithosphere. Emphasize the process of evaporation and infiltration in the conceptual design of the hydraulic cycle. Precipitation and groundwater. So, because we already know the water cycle, we know that precipitation is rain, hail, sleet, snow. Anything that falls from those clouds is precipitation. But little precipitation becomes runoff and is returned to the ocean. The rain infiltrates the ground and becomes groundwater. So when it goes inside the ground, so infiltrate has the word filter. So if it filters in the ground like coffee does, you see how the water goes through the coffee. If I don't know if you know what a coffee maker looks like. But when the coffee and the water is at the top, it infiltrates through the coffee. And then, of course, once the water goes through it and it seeks, you'll start seeing a brown substance come through the bottom, which is what we know as coffee. So, in this instance, this will be called groundwater. Porosity is the percentage of pore space in a material. So as you see here, this is well sorted. So this is have a high porosity here because this is a pretty much almost even amount. Poor sorted sediments give you low porosity because it does not give you that great percentage of pore space. Okay. Groundwater in its movement. So just as you saw how the streams and they have a lot of meanders and stuff, groundwater moves by twisting and turning. Water can, if the water just sitting there, we know pond water and stuff does not move, right? We know water can stay where it's at, but it has to have a twist, a little bit of turn. It has to have small openings for it to get from one place to another. The thing is, when you have smaller pores, it takes a little bit longer for the water to go through. So if you had a crack and you put water in it, you will see the water eventually go through the crack, but it will take a while. The bigger the crack, the more water will come in. So groundwater movement. So groundwater flows downhill in the direction of the slope of the water table. Permeability is the ability of the material to let water pass through it. Now, permeability, again, is allow water to pass through. If it's high permeability, we have large connected pores. So that's going to be like sand and gravel. What do you see at the beach? You don't see clay at the beach, right? Because that's low permeability. You see sand. Okay, water is easily. Why do you think we put gravel on the road? Because you don't want to have water just sitting there, right? So we put gravel so that water can seep through just as it can through with sand. So low permeability will be the fine grain particles will be silts, clay, shale. So that is the deeper layers inside the soil. So as you see here, we have gravel, we have silt, slate, and clay. So again, it's high at the very top because we at the very top. It's easier to go through, but it's thick when we get down there. They don't really have a lot of pores, okay? All right, so groundwater, they have different zones. So you do need to know the zone of saturation and the zone of unsaturation. Obviously, if it's not here, right above it is the zone of unsaturation. And also we can call it the zone of aeration, which is pores are filled with air, as you see in the picture right here. Okay, so air fills spaces between the soil particles. This is this area. Now the water table is the upper boundary zone of the saturation. So this little line right here is considered your water table. The zone of saturation is the depth below that water table. All right, and so this is when water fills, not air. So zone of saturation is when water right here is filling the spaces between soil, and then the zone of aeration is when air fills it. So the topography of the water table follows the topography of the land above it. All right, because it depends on the precipitation, the water table fluctuates with the seasons and other conditions. All right, so here again, it will adjust to whatever is above it. Okay, it's basically easy adjustment. Aquifers are underwater permeable layers where most groundwater flows take place. Okay, so as you see here in the picture, you see how it's right up under the impermeable layer, and then you see the wells and we see the little houses and you see where the water comes from. The impermeable layers are also called aquicludes, which are barriers to groundwater flow. Now here, water table aquifers are unconfined and unprotected and thus easily polluted. All right, so as you see here, it's unconfined. can be easily polluted. It's right up under your house. And I'm going to show you a picture of what can actually happen. Deeper aquifers, which is called confined. If you're more confined, you see all the layers it goes through. It has to take a long time to get there. Now, where would you probably want your water to come from? You probably want to get your water right there from more or less the artesian well, as you see in this picture. You don't really want it from the shallow well, because there's a lot of things that could go wrong. But it has a lot of, right as you see here, the aquicludes forms a barrier that prevents pollutants from reaching such aquifers. As you see here, the non-porous porous material right here that is protecting and separating. So as you see, confined versus unconfined. All right, so confined, we have to go through layers to get what we need. Right here, unconfined, once we get through the land surface and hit, we're right here at the water. This is, of course, where it can get easily polluted. So we do have to talk about North Carolina. Aquifers in North Carolina, as you see here, this is a typical here of the Piedmont and the mountain areas. So we have unsaturated soil, the water table, saturated soil, and then we have the bedrock. And you can see where the water flows within. Here, which is on the coastal plain, which is more for us, we have, as you see, the unsaturated zone, but look at our dirt compared to the soil here in the mountains region. And then, as you see, we have an unconfined aquifer, we have a confining layer, we have all these layers, and then we finally get the confined. So we actually have the confined aquifers. So wells, if you don't know what a well is, I'm a country girl. We had to have a well in our backyard. It pumped water for our house. We didn't have city water. We had to get our own water. And once you get the machines running, the machine will do it for you. But like for instance, in the winter, we had to turn the water on in the house and make it run at night because the pipes were freeze. We don't have city water that is always still going through this. We went through a natural process. So wells are dug or drilled deep into the ground to reach a reservoir of underground water. So you dig a hole and dig a hole until we find the area of water. And what you do is once you produce the water, a well must tap into an aquifer. Once it gets in there, it's a never-ending water cycle. So the thing is, here with wells, we have a drawdown, which is the difference between the original water table level and the water level pumped in the well. We recharge, which is the process in which water from precipitation and runoff is added back to the zone of saturation. And over pumping is basically a well produces a cone of depression around the well. So as you see here, formation of the cone, depression, and water table. So as you see here, before you stop pumping heavy, you notice that the water has now was depleted in one area. And this can happen when you have to put a different well because you have made an area. If someone keeps taking from you and never pour back into you, it's just like a grape. Once we take all the juices out, it kind of shrivels up and becomes a raisin, and basically that's depressing. I don't want to walk around here looking like a raisin. So what happens to our water levels when it drops so much because it was used and taken advantage of in that one area? It becomes like a raisin. It gets depressed. So that's why we call it the cone of depression. There is threats to our water supply. Human demands for fresh water includes that we need it for our house, we need it for farming, we need it for industry. But you see here, cooling of electric power plants, like we can't even do it because you got to think about we need it. Why do you think every time the people build a house or they have a lot of electricity, they build like a little pond? The thing is, another threat to our water supply is overusing. As we keep on increasing, so does the need for the water. If groundwater is pumped out at a greater rate, the thing is, it will basically decrease and the water table will drop. So subsidence, ground subsidence, or the sinking of sand, is a problem caused by excessive withdrawal of groundwater. So this is where you see in this picture, like right where they stand at the ground kind of sinks in. Um, Definitely, like, what's going on? This is taken away from the water source. So if the water was helping keeping the land up, once the water goes down, the land goes down as well. And then saltwater intrusion. So before pumping, we can have a high water table and we at a great place. But the overpumping of wells near the ocean can cause underlying salt water to rise into the wells, contaminating our fresh water. So instead of us having this, you see now the salt water has gotten to our well system, and then our water tastes. I'm glad we don't live by the oceans and stuff, but um, during this time, we can get some of that salty taste. Now, this is what I was saying earlier. When you have different aquifers and stuff, if you are undefined, you're going to be right here by your septic tank. So right here, and if you don't know what your septic tank is, that's where your pee and poop go in your backyard. All right. If that ever leaked, that goes straight into your water. And once it gets there, it gets underground, and so all the water. So this right here again would be your undefined aquifer. And then this is one of your wells. So this is the contaminated well because it's picking up your poop, and I don't think y'all want to drink poopy water. So, of course, here is a part of your book, groundwater pollution sources. All major pollution sources need to be identified and eliminated. So we have to know if you have anything or you smell go in your backyard and it smells stinky, let somebody know. We got to protect our groundwater. Pollution plumes may stop by building of the impermeable underground barriers. Polluted groundwater can be pumped out, okay, and we can treat it chemically.